Hello everyone, this is INE Foundation Lab 3 and section 4.1 RIPv2. Okay, let's refresh RIPv2 concept and I will come back and conclude this section. Okay, there are classful and classless network and classful and classless routing protocols. Let's see the difference between all of these. Classful addresses are IP addresses that use the default subnet mask. These are default subnet mask. Can we have class A, class B, and class C. These are default subnet masks of classful addresses. Classless addresses are those that uses custom mask value to separate network and host portion of the IP addresses. We can use separating in classless addresses and VLSM. We have VLSM in classless addresses. We can separate network and host portion of IP addresses. These are the difference between classful and classless addresses. There is classful and classless routing protocol either. Classful routing protocols do not include default subnet mask information in routing update. In other words, they don't send subnet mask along with the updates. These are how classful routing function. And classful routing protocols are RIPng1 and IGRP. RIPng1 does not send subnet masks in its update. This is the difference between RIPng and RIPng2. Classless routing protocols. Classless routing protocols use a custom mask value to separate network and host portion of IP addresses. In other words, they send subnet mask information in routing update, and therefore they can support VLSM and CIDR. This routing protocol support in other words are classless routing protocols. EIGRP, ISIS, OSPF, and RIPng2 are classless routing update because they send subnet mask information their routing update. Okay, distance vector, link state, and hyperrouting. Let's see the differences between RTF routing. Distance vector is a routing protocol in which routers send their routing table or portion of routing table only to neighboring routers. This is a distance vector routing protocol's function. They send the routing update or routing tables only to neighboring routers. Link state, on the other hand, is a routing protocol in which routers broadcast link state packages or LSPs to all routers in the network or a specific area of the network only when there is a change in our network. This is difference between link state and distance vector. When we have change in our network, then link state routing protocols trigger update and to allow other internet that the broadcast link state packages to all other in our network. There is also hyperrouting routing. Hyperrouting routing is a combination of distance vector and link state protocol. In other words, in hybrid protocol, information is only sent to neighboring routers like distance vector, and information is only sent when it has changed in a network like link state protocol. This is how hyperrouting is functioning. Hyperrouting triggers when there is change in our network, and hyperrouting information is only sent to our neighboring routers. EIGRP is hyperrouting. There is difference between EIGRP and RIP. EIGRP is hyperrouting, but RIP is distance vector. Okay, now let's see RIP version 1 and RIP version 2 and difference between version 1 and version 2. Okay, routing information protocol, or RIP. It is a dynamic routing protocol, and it uses hop count as routing method. Hop count is the number of routers occurring between source and destination network. It uses maximum hop count of 60, and it uses this distance vector routing protocol. Distance vector, it means it sends routing updates only to neighboring routers. It has AD value of 120, and it is located in the network layer of OSI model, and it uses port number of 520, and it has admin distance of 120 by default. This is its AD. Okay, RIP timers include update timer, invalid timer, holder timer, and flash timer. This is RIP timers. And RIP uses loop distance vector loop permission method. Loop permission method in distance vector is or in other words, to prevent a routing loop, or in distance vector, it uses a spread horizon. A spread horizon with position reverse, triggered update, hold and hold on. This is a loop permission method in distance vector, in other words in RIP. Let's see the differences. This is important in this scenario. RIP version 1 sends update as broadcast. This is the broadcast address. RIP version 1 is Classful routing protocol. It uses default subnet mask. Because it is Classful routing protocol, it doesn't send information of subnet mask in its routing update. This is a feature of Classful, and it always uses automatic summarization, and it doesn't support authentication of update messages. This is features of RIP version 1. RIP version 2 features are RIP version 2 sends update as multicast by default. We can change this feature by this command, IPRIP version 2 broadcast. If we type this IPRIP version 2 broadcast, it will use broadcast instead of multicast, like RIP version 1. We have to use IPRIP version 2 broadcast to change multicast to broadcast. It uses multicast address of 224.0.0.9. RIP version 2 is classless routing protocol. It means it sends information of submask in its routing update. This is a feature of classless protocol. And automatic summarization can be turned off by no authorized summary command in RIP version 2. And support authentication of RIP version 2 in update messages. We have another RIP version, it is RIPng. This RIPng can only run on IPv6 networks. It sends update as multicast. It uses this multicast address FF0:9, and it is classless updates. It is classful routing protocol RIPng. And for configuring RIP, RIP configuration is so simple. We simply type router RIP in global configuration. Then we specify network and specify network version 1 or 2. And if we are configuring version 2, we can use no auto summary command. To turn off automatic summarization. To turn off automatic summarization, we can use no auto summary in RIP version 2. And for verifying our RIP protocol, we can use debug IP RIP, show IP route, or show IP route RIP, and show IP protocol. This show IP protocol is general. We can use this show IP protocol for all routing protocols. This is RIP, and now we can configure RIP. This is so simple. Configuration RIP is so simple. And let's see this last concept. This is offset list. The offset list command is used in routing protocols like EIGRP or RIP to influence the metric of routing protocol. This is the job of offset list, to influence metric of our routing protocol. And we can use offset list only for EIGRP and RIP, not OSPF, BGP or others. It allows you to increase the metric when you send the routing update to your neighbor or when you receive it. And it is useful for controlling path selection, and offset list can be configured either by an access list, or we can configure offset list on interface. And for configure offset list by using access list, we simply use type access-list command, specify number, permit, and we specify the IP addresses for our offset list. Then under router RIP configuration, we use offset list, but then we specify access list number. This is the same number we have used in access list, and we type in or out, and we specify our metric number to increase by 10 or other. In pen force offset list on incoming packets, and out is for outgoing updates. This is how offset list is working. This is for inference arithmetic in routing protocol. It is the Java object list. Okay, that's it. This is RIP concept and object list, and how we can use object list for to influence our traffic. And let's configure this section. Okay, let's see what we should do here. Okay, let me show topology. This is our topology. We have BGP. We should configure RIP version 2 between R9 and R1 under this Ethernet 1.19 interface. Okay, let's see. Show IP interface brief. And let's type show IP interface brief in here. This is the interface between R9 and R1. This interface, let's check R9 info connectivity. Repeat one. Okay, connectivity is working. Other side is 19.1 and this side is 19.9. Okay, let's configure this section. Okay, configure RIP version 2 between 1 and 9. It says we should use RIP version 2 instead of RIP version 1. And advertise the loopback 0 of RIP, loopback 0 of router 1 and R9 into RIP. We can advertise this loopback by network command. Okay, let's do this section on the RIP configure. Configuration is so simple. Simply config t router RIP version 2 and advertise loopback network. First, we have to configure. Let's see. That's 0, 255, 255, 255. Okay, we don't have mask. Just network. And turn off automatic summarization, no auto summary. This is this part. Do the tip. Version 2 network. this network. Water sound. And we have to also add this our loop back top network 1111 network 999. Okay, now let's verify to show IP route RIP. For the show IP route RIP, we can see that number 999 the loopback is advertised here. Let's check here to show IP route RIP. And this network that advertised for R1. Do show IP interface brief. There is two more addresses. And this tunnel. Okay. Okay, let's configure R1 so that our non-loopback 0 is installed in RIP with metric of 15. Okay, let's see the metric of R9 the metric of loopback 0 of R9 on R1. The metric is this administered instance, and the metric is 1. We have to configure R1 so that our non-loopback 0 is installed in RIP with metric of 50. we have to increase this metric of loopback 0 of R9 on R1. Okay, let's use we can achieve this goal by offset list. Offset dash list. So let's create access list. Let's come on R1. I type access list. Let's see access list number none. Permit. I have to permit this network 9999 because I want to upload this. And I have created access list. Then I have to go on the router RIP and type offset list and type our number. This is access this number. And if I receive this incoming, this is perform offset is incoming receive. If I receive this from R9, this update from R9, then it says it should be 15. Then my current is 1. Then I have to increase in 14. 14 plus 1 is 15. That's it. And let's check to show output RIP. Let's clear output. Excellent. IP fabric. Okay, let's clear IP root. Clear IP root. Clear IP root start. show IP route RIP. Now we have number 50. That's it. Or we can influence our metric by offset list. Here it says we have come to R1 so that our 9 loopback 0 is installed in RIP with metric of 50. We have just created access list to show down. I have created access list and match our network that I want to increase its metric, and under router RIP I use offset list my access list, and inbound if I receive update from R9 it will increase our metric to 14. Current one is 1, current metric is 1, the 1 plus 14 is 50. This is how we can influence our metric. So this is done. And ensure that R9 does not see a route to this network, and don't use distribute list to accomplish this task. Okay, let's check R9. And to show IP route RIP. Okay, this is this network. It says okay, we can use offset list here either and change metric to 16. We can use distribute list in this task, but we can use offset list instead. Okay, let's create access list. Simply create access list here. Access list type, let's say standard access list. I create 99 and permit, and I have to permit this network. Permit 128 10 100 0 and 0. This is 0, and I have to use wildcard bits 0 0 0 255. This is opposite. This wildcard bit is opposite of all mask, subnet mask. This is 255 255 and this one. Okay, now I go to router RIP and create offset list. Type my offset list, and I type inbound if I receive this from other side. Then set the metric offset to into to 16, it will not allow this to be installed in RIP. Okay, this was my previous RIB or routing information base routing. Oh yeah, this network. Now let's check. Let's clear a network. Let's show IP routing. Okay, now it's gone. I don't have to clear this my routing. This network has gone because it's now arithmetic of 16. Good, that's it. Now we can force our node to not see this network. Can use offset list and set metric to 16 because RIP's maximum hop count is 16 as I explained before. This is it uses maximum hop count value of 16. Okay. Now this one. Okay. Ensure that no RIP version 2 updates are sent on interfaces facing other routing domains. Okay, it means we can achieve this goal by passive interface command. Passive interface. Simply I enable passive interface on all interfaces and disable this passive interface on this interface between R9 and R1. Okay, let's enable config T router RIP. I enable passive interface, and I type this should default. Okay, this is passive into default. This is default. Okay, passive into default is this command. Dial. This command will enable passive interface on all interfaces. Then we can disable passive interface between R9 and R1 and simply type no passive interface Ethernet should be this one. Same on R1 config T. go to RIP, passive interface default, and no passive interface, this one. Okay, I can verify by do show IP protocol, and here and do show IP protocol. To show IP protocol, it says passive interfaces on our non-used all. This is our passive. Instead, this one. One. These are our passive interfaces for RIP. For RIP protocol, these are passive, and this is my interpreters updates are going. This is what the program RIP. Okay, that's it. No updates are sent on interface facing other routing domain. This is done by passive interface. And it says configure RIP between R1 and R9 to send broadcast updates. Okay, as I explained before, RIP version 2 it sends update as multicast by default. We can change this multicast to broadcast by this command RIP version 2 broadcast. Okay, let's go under this interface. Interface Ethernet. This interface. IPRIP. We have version 2 broadcast. We send IP broadcast version 2 update. Same on here. On simply go interface and RIP IP version 2 broadcast. IPRIP version 2 broadcast. Okay, let's verify. I can verify this by debug. Debug IPRIP. I just ping 255. Now let's check. It says RIP sending version 2 update to this is our broadcast address via this interface, and this is and RIP received version 2 update from this network, and this is our metric in 15 hubs. This is how it is working. It sends broadcast instead of multicast. Okay, let's check if this network is not installed in RIP. Can verify this here. On our 9. For now, I start debug. IPRIP. Items UI honest and broadcast. Okay, now receive update, and it's sending version to update in broadcast. Here, this is this line inaccessible. This is the network that says in 17 hubs. We have increased metric of that network by offset list, and it is inaccessible. This is for this part of the section. One does not security because we have increased metric to 70. Okay, that's it. This is how RIP version 2 is working, and I hope you have enjoyed this video, and thank you for viewing.